now. All right, and so what we're going to talk about today, sort of the next step to what we were doing with factoring. And so the overarching theme of this entire week is going to be solving quadratic equations. And I want to show you what I mean by that. Because there's a bunch of different ways of doing it. And so what I'm going to do is roll through, talk about how to do some things at the basic level that we're going to be talking about today. And then we're just going to, this week, we're going to keep building up the skills for something like this. The other thing that's going to be nice is that with this, I am going to keep these recordings up as like videos that you guys can access through the Google Classroom. And I'm not going to archive the Google Classroom until probably August. So if this is something that you need to go back and watch something leading up to, getting yourself ready for the summer homework stuff, these are all available for you to look at, and that should be fine. And I just got another quick question about winter textbooks due. I went through all of that earlier, but I'll just say really quickly, the 2 official turn-in days are going to be Tuesday and Wednesday of next week from 1 to 4 p.m. You can just drive by and drop them off, and it should be fine. If I'm going to give you more information, I'll do that tomorrow. Okay, now, solving quadratic equations. First, let's talk about what they are. If we're going to talk about a quadratic equation, legit, the only thing that makes it a quadratic equation is that. If you are solving an equation that has that in it and it has an equal sign and there's something else, that's a quadratic equation. Now, as long as there are no exponents higher than 2 and nothing really, and all of the other exponents that are in there are going to be like whole number values, you're fine. You don't have fractions or negative exponents. You've got like, if this is what we're talking about, this makes it a quadratic equation. The reason why this is something that we have to go through a couple different iterations with is because this functions a little differently. We've definitely solved something like this before, so I'm just going to start with the very most basic, and then we're going to leave this for something else in a minute, because problems like this one are kind of awesome in terms of solving them, right? So like, I'm willing to bet most of you guys could tell me right now, looking at this, what x would have to equal, right? So toss it up in the chat. Let me see what you got. If x squared equals 4, what does x equal? Because we're solving for x. Ian's got 2, V's got 2, lots of 2s. You guys are right. I mean, you know what squared is equal to 4. Ha ha, Will. Will wins. Will is the first one. So you've got more than one option. And that is the problem with these. When we're talking about solving quadratic equations, because you're squaring a variable and you want to find all of your possible answers, there's more than one answer that's going to make this true. So at the end of this, I'm going to tell you that x could equal 2, which we absolutely know. 2 squared is 4. But because when you square a negative number, it becomes positive, you have 2 answers to this. And in fact, there's this thing called the fundamental theorem of algebra, which when you get to algebra 2, you're going to start talking about, and definitely pre-calculus. What it comes down to is the exponent of the highest exponent of your top variable tells you how many possible answers there are to an equation that you have. There are 2 possible answers because this is x to the second power. Now, there's a whole proof that could go into that we're not going to get into today. But because it's x squared, there is always 2 answers. Sometimes they look a little different. Sometimes we have to deal with how to look at them. But that's what makes quadratic equations a little bit more challenging in how you go about solving them, is that you have to consider all possibilities. And with simple equations like this one, they're kind of easier to find. The problem is the sorts of things that we're going to be working with is, what do you do when you've got x squared minus x minus 6 is equal to 0? If I'm solving that, there's more crap to deal with. You've got more moving parts. There's 2 x's at the same time. How do I handle that? And that's sort of where we're going to start with today. So when we're talking about solving quadratic equations, the biggest thing I want you to remember is there's 2 answers. And then after you remember that, how we get to those 2 answers, that kind of involves a lot more stuff. So let me do this first as kind of a reset of solving equations that I'm interested in using a little bit of time to kind of explore here. And that's going to be not calling them x's. These aren't quadratic equations per se, but I'm going to write just a couple things here. Let's just use 2 variables, a and b, right? So I'm not going to worry about these x's yet. And right now, they're being multiplied together. And I want to kind of explore an idea here for a minute. So if I have a product of 2 things, and it's equal to a number. Let's say in this case, the number is A times B is equal to 12. Let's use that just as an example here. Right now, could you tell me with any definite surety what A or B is equal to? Like, give me some ideas. A equals what? So V says nope. Well, that's probably true because I wouldn't ask the question that way if it wasn't true. But let's try a couple things just to see why there might not be any surety of this. A times B equals 12. What could A and B be? There are a lot of answers. Give me some examples. So I got 12 and 1, 6 and 2, 3 and 4. Okay, so a lot of negatives that are here too. So I'm going to show you this for a second. A lot of what I'm seeing right now are the factor pairs of 12, right? So we've got 1 times 12, those could be flipped. We've got 2 times 6, those could be flipped. We've got 3 times 4, those could be flipped. These could be plus or minus depending on what we're looking at for positives and negatives. So one of the things that I think is important to kind of think about is right now, what we've just listed out here are a total of, well, let's think. There are 6 possibilities of numbers, and then you multiply that 2 for positive and negative. So right now, these could be any of 12 things that would be paired with something else. Here's another one to consider. What if I said that A was 24? Couldn't I make B into 1/2? Wouldn't that also work? I didn't say that they had to be whole numbers, right? And I think that's the part about this that's a struggle, is that when you're finding a product of two things that you don't know what they are, like if we knew one of these, that limits us down to saying, oh, well, if I know A is equal to 12, then B has to be 1. Or if I know A is equal to 3, then B has to be 4. Like that's real helpful. But the problem is when we've got two variables like that, there is an infinite number of possibilities. So what we need to do is to narrow this down in such a way that if we can limit what they multiply to, if we say, well, if I have two things being multiplied, the answer has to be this because it indicates what one or the other is going to have to be. That's kind of where I want us to go. So can you guys think of, if I try this again, can you guys think of a product number that I can use that would limit these enough that I could say, well, A or B has to be this? Can you think of something I could write here as a number that would be there? So somebody said, so Megan's got 3. Now let's think about that for a minute. That is a prime number, so that does limit us a little bit, where we've got 1 and 3. But what we have to remember is that couldn't I still do those fractions? Like if I made 1/2 times 6 or 1/3 times 9, or I could go forever with these. So there's still an infinite number there. But try something else. Give me another possibility that we could use as a number here as a product that would limit this, where if I have this number, either A has to be this or B has to be this, where it indicates one of them. Maylin has thrown out the number of 0 privately, and I'm going to say that sort of shortens us up. And actually that came right after a couple other people. So we've got V and Ian, both also said that as well. Think about that 0 for a second. If I have 0 as a product, it is the only product that indicates what one of these two things has to be. Because even if I had the number 1, I've got an infinite number of pairs that would absolutely work to get me to 1. I could do 1/2 times 2. I could do 1/3 times 3. I could do all of that's going to work. With 0, the only way you can multiply to get to 0 is if A equals 0 or B equals 0. And that limitation allows us to help solve problems where when we're figuring this out, we can say, okay, if one of these two things has to be true, well, then I know that I can solve for what would make this 0, what could make this 0, and I'm in better shape. So right now, and don't worry about that. Right now, if any of you guys are late because you're getting the COVID vaccine, get the damn COVID vaccine. I do not need, like, this is all being recorded. Great. This will all be here. You can go back. You can see it. It's going to be lovely. I do not care. Get yourself vaccinated. Keeps us all out in the world. You guys saw all that CDC stuff. You can basically go out and do whatever you want, which that's what we're looking for. And it means we get to come back in person so you guys can get lost in the building. And that's the very best thing. Okay, so here's what I want us to do. This right here is called the 0 product property. And it's important enough that it has a name, because essentially what it means is that if you set up a multiplication problem and the answer is 0, It's the only number we can have as an answer that indicates what the two factors would have to be. Now, I want to take us back to something for a minute and show you how the zero product property comes into play when we are looking at solving a problem like this. But really, I want to use this. We know what this answer is, right? Right now, x squared equals 4. We know that 2 or negative 2 are our possibilities. And we'll get to solving this in a second. But I want to show you something that I love about math. I saw this thing. Well, you know what? I don't have enough time to go into a story. I saw something that was like people got really angry about the way a teacher graded a test because there was more than one answer. That's the way math is. There's like a million answers to things. So as long as you can explain what you did, you're probably right. Well, probably not. Some people might be wrong, but if you can explain what you did and you're right, then there's more than one way of doing it. This way, we know there's 2 or negative 2, as Will helped point out to us. But what I want to show you is the fact that zero product property works means I can actually set this equal to 0. I'm going to subtract 4 from both sides. X squared minus 4 is equal to 0. This is an equivalent equation. I just moved this over to the other side. It's set equal to 0. Now, it's not set up right now where this is written as two things being multiplied. But what we can recall from what we learned about factoring last week is I've got two things being subtracted, and they're both perfect squares. So this can actually be written as a multiplication problem. X plus 2 and x minus 2. Now, if we take this as our a times b equals 0, I know that either this set of parentheses has to equal 0 to make this true, or this set of parentheses has to be equal to 0 to make this true. So if I set both of those equations up, x plus 2 equals 0, or x minus 2 equals 0, let's see what my two answers are going to be. Let's see, I solve this, and this is x equals negative 2. I solve this, and this is x equals positive 2. Well, damn, that's what we had right up here. So what I'm saying to you is what you can use is sometimes you can use here, essentially we just took a square root of both sides to figure this out, and that works for that type of problem. But when we run into a problem like this, to be able to find out what those answers are going to be, we've got to factor it first so that we can employ the zero product property and say, well, now that it's factored, either this is equal to 0 or this is equal to 0, and we can solve it. And you get the same answer. Now, what we're going to do tomorrow when we come back in is work on how do we factor these things? What do we have to put in place? And what are sort of the ins and outs of like factoring to solve these equations that would make something like this work? Now, we only got about a minute left, so I'm not going to throw a bunch of other things in there. But I think this makes the case for why we have to do it to use the zero product property. Then as this gets more and more complicated, as long as it's equal to 0 and I can factor it, we can use this process to solve for an equation. Are there any questions about this before I stop the recording and kind of get rolling through here? This is where we use the quadratic formula, and I am going to definitely build up to that. There's a process of using factoring to solve that I want to make sure we have first. Then we're going to lead into something called completing the square, and then we're going to talk about developing that into the quadratic formula. So it's a 3-day set that I'm probably going to have to stretch to 4 days, but we'll get there, and it's going to be fine. Because again, no new material this week. All that you guys are going to be doing is going back, finishing that quiz that we had at the end of last week, the factoring quiz, getting any old quizzes done, and then going from there. Okay. Now, what somebody did ask me really quickly, would 1 work as an answer for this? It wouldn't for this reason, because 1 plus 2 is 3, 1 minus 2 is -1, and 3 times -1 would give me -3. The only way that you can make the answer 0 is by making one set of parentheses or the other set of parentheses 0. And for the a times b, 1 doesn't work as a product because I can do a whole lot of different pairs, like 1/2 times 2, 1/3 times 3, 1/5 times 5 to get to 1. And that's the reason why. Fractions are our friends, guys. Just like fish are the shark's friends. That's right, Nemo. It's great. Anyways, guys, that's the end of our class today. Have yourselves a lovely day. We'll see you same bat time and same bat channel tomorrow. And then we will find our way into the end. Go get some work done. Bye, everybody.